at exact differential equations today. So this is another type of differential equation that we look at. Now, classifying our differential equations helps us to know how to solve them. So what is key is you should be able to identify, say, this one is exact, this one is homogeneous, this one is linear, and so on. So today, like I said, we look at exact differential equations. Okay, so what is a differential equation? This is when you're given something like this: p dx plus q dy is equal to 0. So p here is a function of x and y, and q is also a function of x and y. So it contains x terms and y terms, or they both contain x terms and y terms. Now we say that this differential equation is exact if we differentiate p partially with respect to y, and we differentiate q partially with respect to x, and then if these two are the same, then we can say that the differential equation is exact. Okay, so you take this function here, p, differentiate it partially with respect to y, take q, differentiate partially with respect to x, then if the two answers are the same, then we can say that the differential equation is exact. And then when we have classified the differential equation as exact, the way we solve it is we can either integrate p with respect to x. This will give us a function, say f1, in terms of xy. Now, if I'm integrating a function with respect to x, but I have a function that is in terms of x and y, instead of having a constant over here, I will put a function of y, because if I were to differentiate this, this is a function of y, it doesn't have any x. When I differentiate it, the derivative is 0. So instead of a constant, I have a function of y. Or I could integrate q with respect to y, then I get some function here, xy plus g of x. So again, instead of a constant here, I have a function of x, so it has x only, so that when I differentiate it with respect to y, the derivative is 0. Then we have to solve for these two functions. So either you do it this way or that way, so you have the option, you don't have to do both of them. So you pick which one you want. Usually you'll pick the one that's easier to integrate, whether p with respect to x or q with respect to y, and then that is what you get. And then to solve for this f of y or this g of x, what we will then do is this one here, we will differentiate it with respect to x to y, and then equate it to q. And this one, we will differentiate it with respect to x and then equate it to p, and then we'll solve. Okay, so it's easier when we look at an example, then we understand what it is we have to do. So let's look at an example. So we have number 1, 2x plus 3y plus 4 dx plus 3x plus 5y minus 2 dy. This is equal to 0. So first we must check and see, is this exact? So we need to identify our p. This is 2x plus 3y plus 4. And then our q here is 3x plus 5y minus 2. Then to check, we differentiate p partially with respect to y. So when you differentiate this with respect to y, this doesn't have a y, so the derivative is 0. And the derivative of 3y is 3. And this is a constant, its derivative is 0. Then I have the derivative of q partially with respect to x. The derivative of 3x is 3. The derivative of 5y is 0 because there's no x here. The derivative of minus 2 is also 0. So you can see that the partial of p with respect to y is equal to the partial of q with respect to x. So these two are equal. Therefore, the differential equation is exact. So that is something you must check. See, is it exact? If it is, then we proceed to solve it. Okay, now the way we solve it is we have to integrate either p or q. Which one you choose is really up to you. If I choose to integrate p, I must integrate it with respect to x. If I choose to integrate q, I must integrate it with respect to y. So here I will integrate p. So I have the integral of p dx. This is the integral. What is my p? This is 2x plus 3y plus 4. Thus 3y plus 4. We integrate with respect to x. So this is equal to 2x squared divided by 2. And then I have 3xy plus 4x. And then instead of putting a constant, I am going to put a function that is in terms of y only, because when I differentiate this with respect to x, the derivative of this one is going to be 0. Okay, because it's a constant, it does not contain x if I'm differentiating with respect to x. So now that I have this derivative, what I do is I differentiate this function with respect to y. Okay, and that answer must be equal to q. So take this function, differentiate it with respect to y. So if I simplify this, this is just x squared. Okay, so this would be your function f that you're looking for. Okay, so now I take f and I differentiate it with respect to y. So the derivative of x squared is 0. There's no y there. The derivative of 3xy with respect to y is 3x. The derivative of 4x with respect to y is 0. And then this function here, when I differentiate it with respect to y, I just get f prime of y. It's the derivative. And this derivative is what I want to solve. And we said when you differentiate this, it must be equal to your q from the question. So what is q? Go back, q is here, it's 3x plus 5y minus 2. So I have 3x I have 3x plus f prime of y. This is equal to q, and q is equal to 3x plus 5y minus 2. So you can see these two will cancel. Then this means that f prime of y is equal to 5y minus 2. Okay, so now I know the derivative of this f. I need to find the f, and then that will tell me the function that I'm looking for. That solves everything. Okay, so to get this function f, I need to integrate with respect to y. So I integrate f prime of y with respect to y. This is the integral of 5y minus 2 dy. So this gives me f of y is equal to 5y squared over 2 minus 2y, then plus my constant. So that is going to go over here, and that is the solution. Now the way we write the solution is as follows. Say our solution is, we take all these terms here. So it will be x squared plus 3xy plus 4x, and then f of y is this part, and then we equate it to c. So our solution is x squared plus 3xy plus 4x plus 5y squared over 2 minus 2y, and we say this is equal to c. So that gives us our solution. Okay, so exact differential equations, pretty simple to deal with. Again, you can see we're doing integration, so you do need to know your integration techniques. 2, we have to solve y cos x plus x plus, forgot the dx, plus cos y plus sin y dy, and this is equal to 0. So this is our P, and that is our Q. So we need to check, is this differential equation exact? Here, because we are under the we're under the topic exact differential equation, so obviously it will be exact, but in a test you will just get a differential equation. You won't know whether it's exact or not, so you do need to test it. So I want to see how you test it, and you work out dp dy. So that means you take this and you differentiate it with respect to y, and the answer is cos x. And then you also work out dq dx. Then did I write this question correctly? No, this is an x here. Okay, so then I differentiate this with respect to x, that's 0. The derivative of sine x is cos x. So you can see that these two partial derivatives are the same, and we can say the differential equation is exact. And now that it is exact, we know how to proceed. What you do is you pick which one are you going to integrate, either p with respect to x or q with respect to y. You must just pick one of them. Whichever one you pick is up to you. Try and pick the one that is easier to integrate, or look forward and see, because you will still need to integrate again. But again, that comes with practice, so that you know which one you need to integrate. Okay, so now we integrate So I'm going to integrate p with respect to x. This is y cos x plus x dx. This is the integral of cos x is sine x. So I have y sine x. And then the integral of x is x squared divided by 2. And then instead of adding a constant c, I add a function of y, because when I differentiate this with respect to x, see, I have y cos x, and then the derivative of this with respect to x is 0, because this only contains terms with y. There is no x. That's why its derivative is 0, and I'm back here where I started. Okay, so this is what I have. Then from here, what you do is you take this one and you differentiate it with respect to y. Okay, so I call this fy. So I've integrated with respect to x. The next step is to differentiate with respect to y. And this gives me sine x. The derivative of this one is 0 because there's no y term. And then I have f prime of y. And now that I have differentiated with respect to y, my answer must be equal to q. And this is q, cos y plus sine x. So we can already see that f prime of y is equal to cos y. So this means that sine x plus f prime of y, this is equal to cos y plus sine x. See, these two can cancel. You take one to the other side, they give me 0. So this means that f prime of y is equal to cos y. And now I want to find f of y. To do that, I integrate with respect to y. So the integral of f prime of y dy, this is the integral of cos y dy. So f of y, the integral of cos is sine. And now I add a constant, not a constant in terms of x. It's now just a constant. Okay, and then I write down my solution. So the solution will be this y sine x, x squared over 2 plus this f of y that I got, and then equate everything to c. So this will be so y sine x plus x squared over 2, and then plus f of y. F of y is sine x, sine y, sorry, and then we say that this is equal to constant, and then that is your solution. So we can see that there are just a few steps. If you follow each of them exactly, you will always arrive at the answer. So let's look at some of the questions in exercise 5.6. Let's start with number 1. We have x plus 2y dx plus y plus 2x dy. This is equal to 0. So this is my p and that is my q. Check and see that it is in fact exact. So I will differentiate p partially with respect to y. The answer is 2. I'll differentiate q partially with respect to x. The answer is 2. They are equal, therefore it is exact. So now that I see that it is exact, I can use the method for solving exact differential equations. So this time I'm going to integrate q with respect to y. So notice it doesn't matter which one you pick. You can integrate p with respect to x and then differentiate with respect to y, solve for the function of y and then substitute, or do it the other way. So integrate q with respect to y. This is y plus 2x dy, which is y squared over 2 plus 2xy, and then instead of a constant I put a function of x, because again when I differentiate this with respect to y, this will give me y, this will give me 2x, and this will give me 0. So I'm back there. Okay, then what we do here is we now can call this one our f. So this is what the function will look like with a c, with a function of x missing there. Okay, and then now we find fx. So we differentiate this function with respect to x. And when we do that, the derivative of this with respect to x is 0. The derivative of this with respect to x is 2y. And then the derivative of f of x is just f prime of x. And remember, this must be equal to p. So this means that 2y plus some function f prime of x, which we have to work out, is equal to our p here, which is x plus 2y. And then you can see that the 2y's cancel. This means f prime of x is equal to x, and therefore f of x is x squared divided by 2. Okay, so now I have plus c, now I add the constant of integration. Okay, and then my solution is going to be y squared over 2 plus 2xy plus x squared over 2 is equal to the constant of integration. My solution, we have y squared over 2 plus 2xy plus x squared over 2 is equal to the constant of integration. And just like we were doing yesterday, I noticed a lot of the solutions in the book are made to look nice. So you can multiply everything by 2, so you don't have any fractions. So you have y squared plus 4xy plus x squared, and then here if you say 2c, 2c is a constant. Okay, when I multiply a constant by 2, when I multiply a constant by 2, the answer is still a constant, so I can still just write it c like that. Okay, but this is just as good as that one. I don't think it makes that much of a difference, but that is our solution. Okay, somebody's saying something. Okay, so what you can do is try doing it the other way. Integrate p with respect to x, differentiate it with respect to y, equate it to q, and then find your g prime of y, and then substitute and see, will you still get the same answer? And if you've done it correctly, the answer is yes. you should still get the same answer. Okay, so get number 2, still from your exercise. Number 2, we have 3x minus 4y plus 1 dx and minus 4x minus 5y plus 3 dy. This is equal to 0. First, you need to identify your p and q. So my p is 3x minus 4y plus 1. And this time your q, there's a minus here. Remember, the way that we look at our exact differential equations, there must be a plus here, not a minus. So if you have a minus, that minus must be multiplied with whatever you have there to be part of the q. Okay, so be careful with that. So our q is going to be negative 4x plus 5y minus 3. So this negative I multiplied inside so that there is a plus between them. Okay, so it must be p dx plus q dy is equal to 0. Then we check and see if this is exact. So dp dx dy, this is equal to minus 4, and then dq dy, this is also, am I saying y? This is also equal to minus 4. And notice if I had not multiplied this inside, I would think that the derivative of this with respect to x is 4, and then that one is minus 4, and then I would think this is not exact, when in fact it is exact. Okay, so these two are equal. This means that it is exact. So now that we know our differential equation is exact, we can solve it the way that we always do. So I'm going to integrate p with respect to x. This is 3x minus 4y plus 1 dx. This is 3x squared over 2 minus 4xy plus x, and then plus, let me just take it to the next page. Write this. Okay, so we say this is 3x squared divided by 2 minus 4xy plus x, and then I add a function of y. So this part here is part of the solution. The only thing that I'm missing is this f of y. So we will say our f is represented by 3x squared over 2 minus 4xy plus x plus f of y. Then now I differentiate it with respect to y. And then for the first one, derivative of this is 0. Derivative of this is minus 4x. Derivative of x is 0. Derivative of this one is y prime of of y. And this must be equal to q, which is minus 4x plus 5y minus 3. So I have minus 4x minus 4x, those two will cancel, and therefore we say f prime of y is equal to 5y minus 3. And then to solve for f of y, we integrate both sides with respect to y. This is f of y is equal to 5y squared over 2 minus 3y, and then I have a constant of integration. So then I take this part here and this part here and equate it to c. So my solution will be 3x squared over 2 minus 4xy plus x plus 5y squared over 2 minus 3y, and then this is equal to c. So again, you can try and make it look nicer, maybe multiply by the 2 throughout, but this doesn't look too bad. Number 4, we have y squared minus x squared dx as 2xy dy is equal to 0. So our p is y squared minus x squared, and q is 2xy. So we differentiate this with respect to y, we get 2y. We differentiate q with respect to x, we get 2y. So you can see our derivatives are the same. So this differential equation is exact. Then we can integrate q with respect to y. This is the integral of 2xy dy, which is x y squared plus some function of x. And then this, I will differentiate it with respect to x and equate it to p. So you can say our f will look like this, x y squared plus some function that has only x terms. Then I differentiate with respect to x. What I get is y squared plus f prime of x, and this must be equal to y squared minus x squared, which is p over here. So the y squareds will cancel. That means I have f prime of x is equal to minus x squared, and from here I can work out f of x, which is just the integral of minus x squared dx. And this is equal to minus x to the power of 3 divided by 3 plus my constant of integration. So now I write down the solution. The solution will be this part here plus this part there, and I equate it to c. So my solution will be x y squared plus or minus x to the power of 3 divided by 3, and this is equal to c. Okay, so again, you can multiply by 3 throughout. Just remember that when I multiply this constant by c, when I multiply this constant by 3, I still have a constant, so I don't need to write 3c or something like that. Just write c to represent the constant. Okay, so that's that one. Number 6, sine x minus cos y dx plus x sine y dy is equal to 0. Here our p is sine x minus cos y. Q is x sine y. Okay, differentiate dp dy. This is equal to sine y. And then dq dx. This is also equal to sine y. So we can see these two are equal. Therefore, our differential equation is exact. So again, in a test, most probably you will not be told this is an exact differential equation, unlike here where under the topic of exact differential equation, so we know it's going to be exact. So there is marks for you testing it and then identifying it. Don't just start integrating without showing that it is in fact exact. So I integrate p with respect to x. This is the integral of sine x minus cos y dx. This is the integral of sine x is minus cos x. And the integral of minus cos y is minus x cos y, and then we add a function of y. Okay, so this represents your function f here. Now you want f differentiated with respect to y, and this will be 0 and x sine y. And this must be equal to q, which is x sine y. Sorry, I forgot to differentiate this one, or to write the derivative. So this is plus f prime of y, which is x sine y. So you can see the x sine y's will cancel. So this means that f prime of y is equal to 0. And this means that f of y is just a constant. Okay, so my solution will be minus cos x minus x cos y is equal to a constant. So I have okay, and then this one definitely looks nicer if we multiply everything by minus 1. So say x cos y plus cos x is equal to c. Again, I don't need to write negative c here because negative c is a constant. So this c represents whatever constant you may have over there, whether you multiplied that constant by -1 or not. That is your final answer. do number 7. We have y ln of x minus 1 over x dx minus x minus x ln of x dy, and this is equal to 0. So again, you can see here I have negative between these two. We must have a plus here. So when we have a negative, this negative must go inside the bracket and be part of our Q. So we have P is equal to y ln of x minus 1 over x, and then Q is x ln of x minus x. Okay, now we can check and see whether it is in fact exact or not. So we have P differentiated with respect to y. This is ln of x, and then Q differentiated with respect to x. Differentiating this one, we must use the product rule. So the derivative of this one multiplied by ln of x, and then we add this one multiplied by the derivative of this, so that's x times 1 over x, which is 1, and then the derivative of minus x is minus 1. So you can see that dq dx is equal to ln of x, and those two are equal. So this one is equal to that one. Therefore, we can say that it is in fact exact. So now that we know that it is exact, we can proceed the way we always do. Okay, so here what I'm going to do is I look at these two, P and Q. If I want to integrate this with respect to x, I'm going to have to integrate ln of x with respect to x, and to do that I must use by parts. I don't want to do that. But if I integrate this one with respect to y, it's just a matter of adding a y everywhere. So that's easier to integrate. But you'll see later on we still have to integrate that. So yeah, but it's easier to integrate this with respect to y than this one with respect to x. So I'm integrating q with respect to y. Which is the integral of x ln of x minus x dy, and this is xy ln of x minus xy, and then I add some function of x. Okay, so this represents my f, and what I need to do is differentiate this f with respect to x and then equate it to this one. So I find fx. So I have to integrate x, y, ln of x. Again, here you must use the product rule. So the derivative of x is 1, so I have y ln of x. And then the derivative of y ln of x is y over x. So I have y over x times x, which is y. And then xy, the derivative with respect to x is minus y, sorry. And then the derivative of f of x is f prime of x. And this we must equate to p. So we can see that these two will cancel. And then I have y ln of x plus f prime of x. This must be equal to p. P is y ln of x minus 1 over x. So those two will cancel. So this means I have f prime of x is equal to minus 1 over x. And this means that f of x is equal to minus the integral of 1 over x dx, which is minus ln of x plus a constant of integration. So now I write down my solution. So the solution will be xy ln of x minus xy. That's the first part. Xy ln of x minus xy. And then I add this part here and then equate it to c. So minus ln of x, and this is equal to c. So that is my solution. Again, you can try doing it the other way. Integrate this one with respect to x, then differentiate it with respect to y, equate it to this one. Your answer should still be the same, but like I said, try and always pick the easier one to integrate. So between these two, it was easier to integrate that one than that one. Here's number 7. Number 9. Okay, so we need to check if this is exact. So P is 10x plus ln of y, and Q is x over y. Differentiate P with respect to y. We get 1 over y. Differentiate Q with respect to x. We get 1 over y. So these two are equal. Therefore, our differential equation is exact. Okay. Then, I don't know why it's flashing. Then we proceed in the way that we always do. Either I will integrate this with respect to x or integrate this with respect to y. So I think it's much easier to integrate this with respect to y than that one. It's not that much difficult to integrate this one because tan of x is just sine over cos, and then it's not that difficult anyway, right? But what I'm going to do is I'm going to find my f by integrating q with respect to y, which is the integral of x over y dy, which is minus x over y squared plus some function of x. And then I find the derivative of f with respect to x, which is minus 1 over y plus f prime of x. Okay, sorry, I don't know what I'm doing now. That is not how we integrate. I differentiated actually instead of integrating. Okay, let me just disconnect it and see if it will come back. Okay, so the way to integrate this is x, then the integral of 1 over y dy, and we know that the integral of 1 over y is ln of y. Just a moment. Okay, sorry. Now this gives us x ln of y plus our function in terms of x, which is f of x. Then we integrate with respect to x, we get ln of y plus f prime of x, and then we have to equate this to p, which is this one here. So we have ln of y plus f prime of x is equal to tan x plus ln of y. So those two cancel. We have f prime of x is equal to tan of x. So we're trying to run away from integrating tan of x, but as you can see here, we'll still have to integrate it. But that's not a difficult one to integrate. So it's the integral of tan of x dx. This is the integral of sine x over cos x dx. The numerator is almost the derivative of the denominator. We just need a negative here, and then we put a negative outside. Then this is minus ln of cos x plus our constant of integration. And minus ln of cos x is the same as ln of sec x plus c. So those two are the same. And then I can now write down my solution. Okay, so the solution will be this part here, x ln of y. And then this part here, and equate this to our constant of integration. Okay, so there is other questions in the exercise that you should try. Very important that you practice. And as you can see, these questions involve integration. So you need to know how to integrate. And just looking at the test, oh my goodness, I don't know what happened there, that you can have your book in front of you showing you these are the techniques that we use for integration, and still you are not able to integrate. So I'm not sure what the problem is there, but in any case, the next test is coming up. This one will be from matrices to differential equations, so I think that will cover everything. Just get ready for that one. This one I'm sure will be, it will not be an open book test because we need two tests that are not open book in order to make up the 100% of your assessment. And then after that we have some quizzes or an assignment that will be your 20%. So prepare for that test and we'll continue tomorrow.